Good morning, students. So this is physics, class 12, chapter number 4, and in this lecture I'll be doing the homework solutions of lecture number 7, and at the last you will be given the assignment of chapter number 3. Okay, so let us start with doubts. So the first question is question number 10. Question number 10 says, two moving coils meter M1 and M2 have the following particulars, and their resistance, number of turns, area and magnetic field is given in the question. It is saying determine the ratio of the current sensitivity and voltage sensitivity. Okay, so first of all, as you know, current sensitivity is defined as alpha upon I, where alpha is the deflection, and again the formula for alpha upon I is NAB upon K. This we have done in the theory lecture. Okay, so just by everything is given in the question, so just by putting the particulars you will get IS1 upon IS2 to be 1.4. Okay, so the second part says calculate the voltage sensitivity. Now as you know, voltage sensitivity is Is upon R. Again Is is NAB upon K. Again put the formula and K. One more thing, K1 and K2 for both of them will remain same. Toroidal constant will remain same. Okay, so it will come to be 1. Okay, so the next question is question number 18. So the question says, so the question has three parts. The first part says a magnetic field that varies in magnitude from point to point but has a constant direction from east to west. That is, the magnetic field is having a constant direction in east to west. That is, we can say magnetic field is lying in minus I cap. Okay, so then the question says a charged particle enters the chamber and travels undeflected along a straight path with constant speed. What can you say about the initial velocity of the particle? If in this magnetic field a charged particle enters and if it is passing undeflected, that means the force on the particle is 0. And as you know the formula of the magnetic force, that is F is equals to Q into V cross B. So that means if either the angle is 0 or 180 degree, the force will come to be 0. So that means the velocity of the particle is either parallel to the field or anti-parallel to the field. So this we can conclude in first part. Okay. So the second part says a charged particle enters an environment of a strong and non-uniform magnetic field varying from point to point both in magnitude and direction and comes out of it in a complicated trajectory. Would its final speed equal to initial speed if it suffered no collisions with the environment? So as you know, the magnetic field is only responsible for changing the direction of the charged particle. It does not change the speed, or you can say magnitude of the speed of the particle. So that means its final speed will remain equal to initial speed. So the answer will be yes. Okay, always remember magnetic field is only responsible in changing the speed, changing the direction of the speed. It does not change its magnitude. Okay, so this next part is an electron traveling west to east enters a chamber having a uniform electrostatic field in north to south direction. That is, an electron is traveling from west to east, so we can say the velocity is lying in plus I cap direction. Okay, and electrostatic field is there in north to south direction, so you can say it is lying in minus J cap. Okay, so if electric field is in minus J cap, the force is QE. That means, and one more thing, there is electron. Okay, so if electron is there, that means its force will be in opposite direction, so you can say force will act in plus J cap direction. Okay, it will be plus J cap. Okay, so the question says specify the direction in which a uniform magnetic field should be set up to prevent the electron from deflecting its straight line path. Okay, so if electrostatic field is in J cap, that means the magnetic field should be in minus J cap. Okay, so now can you conclude what should be direction of magnetic field so that it can be minus J cap? It should be in downward direction. B is downward or inside paper. So when you will put this direction, you will get F magnetic in minus J cap, because now both the forces will be balanced, so it will cut down. Okay, so the next part of the question is question number 26. Okay, so next question is question number 26, and the question says a solenoid 60 centimeter long and of radius 4 centimeters has 3 layers of windings of 300 turns each. Okay, so the length is given, radius is given, and it is given there are 3 turns of 300 windings each. So that means total number of turns will be 300 into 3, that will be 900. Okay, so the next it says Both the wires and the axis of the solenoid are in horizontal plane. The wire is connected through the two leads parallel to the axis of solenoid to an external battery which supplies a current of 6 ampere. That means, suppose if this is the solenoid, a wire is lying like this perpendicularly to its axis and current 6 ampere is flowing through it, and its length is 2 centimeter and its mass is 2.5 grams. Okay, so now you have to tell for what value of current in the windings of the solenoid can support the weight of wire. Okay, so as you know, because there will be some magnetic field inside the solenoid, and that value is mu naught Ni or mu naught Ni by L, where N is number of turns. Okay, so this now, due to this magnetic field, a force will act on this wire, and that value of the force is IBL. So putting the values of B, you will get this much force. Okay, so now in the question it is saying what will be the value of the current for which its weight is balanced. That means this force should be equal to the weight of the wire, only that it can be balanced. Okay, so put the value of force and calculate the value of I from here. You will get it as 108 amperes. Okay. Okay students, now in the next part of the video, you will see the assignment of chapter number 3. Take a note of the questions. There are total 18 questions. Solve them and I'll take your doubts in the tomorrow's video.